Section 7.3 is multiplication properties of exponents. I can raise a power to a power, and I can raise a product to a power. Big ideas for this section. Properties of exponents can be used to simplify a power raised to a power or a product raised to a power. To raise a power to a power, multiply the exponents. To raise a product to a power, raise each factor to the power and multiply. Take note on page 433. Talks about raising a power to a power. To raise a power to a power, we're going to go ahead and multiply the exponents. So, in example 1 here, we have n to the 4th power raised to the 7th power. N to the 4th power is our base. So we're taking our base times itself 7 times. Now, if we look at each one of those factors, the base is n raised to the 4th power, so our base times itself, exponent number of times. So if I were to multiply all of this out and write it all out, this is what I would have. If I count up my n's there, I have 1, 2, 3, 4, 5, 28 of them. Okay, if I counted up all of these, I'd have n times itself 28 times. So rather than writing that out every time, we can use our property here. We have n to the 4th 7 times. So here I could have just added my exponents, and I would have gotten to 28 the same way. And using our property here, power raised to a power, which means a power on top of an exponent on top of an exponent, I can multiply those exponents, and I get to the 28th power. So no matter which way we do it here, guys, we're going to get n raised to the 28th power. So we might as well do it the easiest way, fastest way, and multiply our powers there. So same idea here with b. Here it's a little bit harder to list all of these out with those fractional exponents. So we're going to use our property here. Power to a power, which means an exponent raised on top of an exponent. We just have one base with 2 powers here, 2 exponents. We multiply those exponents. So I take 2/3 times 1/2. With fractions, we multiply straight across. 2/6, which reduces to 1/3. So this whole thing right here reduces to x to the 1/3 power. Feel free to pause here and give these a try if you'd like. Here I have p to the 5th power raised to the 4th power. So my base raised to an exponent raised to an exponent. This means a power raised to a power. Power to a power means we multiply our exponents. And here I get p to the 20th power. On b, same idea. We have one base, 2 exponents. So it's a power to a power. We multiply those. And I get p to the 20th power. So here, it doesn't matter if we have 5 p to the 5th power raised to the 4th or p to the 4th power raised to the 5th. If we were to multiply this all out, whether we had 4 groups of 5 or 5 groups of 4, we'd have 20 p's regardless. So p to the 20th power either way there. Same idea here with c and d. Right now we have one base, 2 exponents, so it's a power raised to a power. We multiply those. Again, with fractions, we multiply straight across and get p to the 1/8 power. And just like with a and b, it doesn't matter that these are in a different order. As long as we have the same values, 1/4 times 1/2 is still going to give us 1/8. So again, one base, 2 exponents means we have a power to a power, one right on top of the other. We multiply them together and get p to the 1/8 power. Here we have a power to a power and multiplication. So according to PEMDAS, okay, we have to do exponents first. Simplify within parentheses, but there's nothing in our parentheses we can do. But our y to the 5/2 power here is raised to the -2 power. So we have to do this exponent before we can do anything with that multiplication. We have a power raised to a power, so here we're going to multiply 5/2 times -2, and we write that as over 1. Multiply straight across, -10/2, so y to the 5th. Second part here, I'm going to drop straight down. I haven't changed it at all, so I still just bring it down as multiplication. Again, my operation is multiplication. Now, we are multiplying powers with the same base. Each exponent has its own base here. So we're multiplying powers with the same base. We keep our base and add our exponents. This is a -5, sorry. We get -2. Now, it's not completely simplified until all of our variables have positive exponents. So I have to move this to the denominator, make it positive, and put a 1 in my numerator. And that is my final answer. -5 from the -10/2. Simplified form of each expression here. We take our base with the 2 exponents there, means power to a power. We have to get rid of that second exponent first. We have to simplify with exponents before we can do multiplication. So here, I take 6 times -4. Because it's power to a power, I multiply my exponents, and I get -24. I bring down my x squared as multiplication. Again, we're multiplying here. I haven't changed that at all or used it yet, so I just bring that right down. Now, multiplying powers with the same base, because each exponent has its own base. I keep my base, add my exponents, and I get -22nd power. But again, we want the simplified form, and this isn't completely simplified until our exponent is positive. So to make it positive, we have to move it to the opposite part of our fraction, here the denominator, change our exponent to be positive, and put a 1 in our numerator. Here in B, same idea. Base raised to 2 exponents means that we have power raised to a power. I'm going to multiply my exponents there. 5/3 times 3 to the first power. Multiply across 15/3, which is 5. I bring down my second W term that I haven't used yet. Here I'm multiplying powers with the same base. Each exponent has its own base. So as long as my bases are the same, I keep that base exactly as it's written, and I can add my exponents. -2 plus 5 is 3. And I can't simplify that any further because my exponent is positive, so I leave it just as W cubed. In C here, make sure we keep an eye on where our exponents go. This -1/2 goes with s to the -5th power. We don't start putting exponents on a variable until we see another variable moving left to right, and we always move left to right. So the -1/2 goes with the s to the -5th power. Here, I have s to the -5/1 times -1/2. Power to a power, an exponent on top of an exponent, means I'm going to multiply those. +5/2. I bring down my second factor, s to the 3/2. And again, here, same base. Each exponent has one base, so I'm going to add my exponents, keep my base. Here I have a common denominator of 2, so I add my numerators. 5 plus 3 gives me 8. 8 divided by 2 is 4. So s to the 4th power. Take note on page 435 is raising a product to a power. To raise a product to a power, raise each factor to the power and multiply. So here in example 3, we're going to find the expression that represents the area of the square. And there's lots of different ways that we can find the area of the square. We can use length times width or side squared. Here, for the sake of this problem, I'm going to use side squared. We can use length times width as well because a square is a rectangle, but I'm going to use side squared just so we can have practice with that property. Now, my side length is 5x cubed, so I'm going to plug that in for s, and I'm going to keep the rest of my problem exactly as it's written. When I substitute that in, I put it in parentheses. Now, my exponent from outside my parentheses, I have to square this entire base. So instead of having my exponent on the outside, I'm going to rewrite it on the inside to each piece. So I'm going to take 5 squared and x cubed squared. 5 squared is 25. X cubed squared, power to a power, 1 base, 2 exponents on top of each other, means I'm going to multiply 3 times 2 and get 6. So, my area here is 25x to the 6th power. I don't have a label, so I'm just going to label it units, and we square it because it's area. We would have gotten to the same place had we used length times width. This just gave us practice with that property. Simplified form of each expression here. Again, you can pause and give these a try if you'd like. Here we take each base and raise it to our exponent. Each base and raise it to the exponent. We distribute that exponent, but keep it as an exponent. Just like when we distribute multiplication, we do it as multiplication. When we distribute our exponent in, we do it as an exponent. So here I'm not taking 7 times 3, I'm taking 7 to the 3rd power, which means 7 times 7 times 7, and I get 343. Here I have 1 base, 2 exponents, which means I'm taking a power to a power, and I multiply my exponents, and I get 343 times m to the 27th power. In B here, we have a couple options. We can either take that exponent inside our parentheses first, or we can get rid of our negative first. I'm going to get rid of the negative first, personally. Okay, in order for it to be simplified, we have to get rid of that negative exponent. So I'm going to move it to my denominator and change it to be positive with a 1 in my numerator. Notice here that that didn't change anything inside my parenthesis. It's still just 2z. The only thing that changed was my exponent became positive. Now, I'm going to rewrite this so that each base gets my exponent. Each base gets my exponent. And now I can actually take 2 to the 4th power, which is again 2 times 2 times 2 times 2, or 16, z to the 4th. And those are both in my denominator because my entire expression was to the negative exponent. Feel free to pause here and give C a try if you'd like. Again, I'm going to get rid of the negative exponent first. We can distribute it in first if you'd like, but I'm going to go ahead and get rid of it to start with, which takes 3g to the 4th power to my denominator and makes it positive. Now, I can take my exponent in to both pieces because I'm multiplying and this is a product. Since all I'm doing is multiplying, I can rewrite it with each piece getting that exponent. So 3 squared, g to the 4th power squared. Keep in mind here that the 4 only goes with the g. It's only touching the g. It's not with the 3. The 2 goes to both pieces because it's touching the parentheses, which means it goes with everything inside those parentheses. Here, 3 squared is 3 times 3, 9. And g to the 4th power squared, 1 base, 2 exponents means I have a power to a power, and I multiply those exponents. 4 times 2 is 8. So I get 1 over 9 g to the 8th power. And that's all I have here for the first half of section 7.3.